Hello student, I am Rohini from KTHM College, Department of Computer Science. Today's subject is Introduction to Cyber Security, having Module 3, Information and Network Security. In this module, today's chapter is Security for VPN and Next Generation Technologies. Today, we discuss about virtualization and cloud technology and security. In previous session, we have discussed about VPN security, security in multimedia networks, various computing platforms like as the HPC, cluster and computing grids. Today, we discuss about virtualization, cloud technology and security. In this topic, we discuss about what is virtualization, then what is hypervisor, and cloud technology and security. Virtualization. Virtualization is the ability to run multiple operating systems on a single physical system and share the underlying hardware resources. It is the process by which one computer hosts the appearance of many computers. Virtualization is used to improve IT throughput and cost by using physical resources as a tool from which virtual resources can be allocated. After that, virtualization architecture. In this architecture, a virtual machine, that is VM. This is virtual machine is an isolated runtime environment like as a guest operating system and here the application. The multiple virtual system means the VM can run on a single physical system. After that, we discuss about benefits of virtualization. First one is cost reduction. Sharing of resources help cost reduction. Then isolation. Virtual machines are isolated from each other as if they are physically separated. Then encapsulation. Virtual machine encapsulate a complete computing environment which is seen in a virtualization architecture. Next one is hardware independence. Virtual machines run independently of underlying hardware. And last one is the portability. Virtual machines can be migrated between the different hosts. After that, hypervisor. Hypervisor, also known as virtual machine monitor or we call as VMM. It is software which create and run the virtual machine, that is VMs. And hypervisor allows one host computer to support the multiple guest VMs by virtually sharing its resources such as memory and processing. Why we can use hypervisor? Hypervisors make it possible to use more of systems available resources and provide greater IT mobility since the guest VMs are independent of the host hardware. This means they can be easily moved between the different servers because multiple virtual machines can be run off one physical server with a hypervisor, and hypervisor reduces space, energy and maintenance requirement. Means these are the benefits of the hypervisor. Let's discuss about benefits of hypervisor. There are several benefits to using a hypervisor that host multiple virtual machines. First one is speed. Hypervisors allow virtual machines to be created instantly, unlike bare metal servers. This makes it easier to provision resources as needed for dynamic workloads. Efficiency. Hypervisors that run several virtual machines on one physical machine resources also allow for more efficient utilization of one physical server. It is more cost and energy efficient to run several virtual machines on a one physical machine than to run a multiple underutilized physical machines for the same task. After that, flexibility. Bare metal hypervisors allow operating system and their associated application to run on a variety of hardware types because the hypervisor separates the operating system from underlying hardware. So the software no longer relies on specific hardware devices or drivers. Next one is portability. Hypervisors allow multiple operating systems to reside on the same physical server, that is the host machine, because virtual machines that the hypervisors run are independent from the physical machine. They are portable. It means IT teams can shift workloads and allocate networking, memory, storage, and processing resources across multiple servers as needed. Moving from machine to machine or platform to platform gain an application more processing power. The virtualization software allows it to seamlessly access additional machines. After that, cloud computing, a large-scale distributed computing paradigm that is driven by economics of scale, in which a pool of abstracted, virtualized, dynamically scalable, managed computing power, storage, platforms, and services are delivered on demand to external customers over the internet. Cloud computing is the on-demand availability of the computer system resources, especially data storage, means the cloud storage and computing power without direct active management by the user. After that, virtualization in cloud computing. Cloud computing takes virtualization one step further. If you use the cloud computing, then you don't need to own your hardware. Then resources are rented as needed from a cloud. Then various providers allow creating the virtual servers. Means you can choose the operating system and the software each instance will have. Then you can also choose operating system will run on a large server farm. So then can instantiate more virtual server or shut down existing ones within a minute. Then you get a build only for what you used. Types of cloud deployment. There are the three types: public, private, and hybrid. A public cloud is owned and managed by the third-party cloud service provider. The main characteristics of a public cloud is that you share it with other users or other companies. In an open computing environment, anyone from anywhere can buy, means pay as they go for what they can use, and small slice of storage in that cloud. You can access the services instantly, which adapts on the go based on your changing needs. Next type is the private cloud. Compared to public cloud, the private cloud is meant exclusively for single business or organization. You don't share a slice anymore. Your organization owns the entire cloud. The infrastructure and services function on a private network. The main benefits of private cloud are cost. The private cloud can be cheaper option. Second one is security. When you manage your system in-house, it means that a dedicated internal IT team is in charge. Means they run the maintenance through a secure network and no other company has access to your servers. Then performance and scalability. Next type is hybrid cloud. A hybrid cloud is the place where the public and private cloud merge, allowing users to share data and application between clouds. A hybrid cloud brings more flexibility and deployment option by allowing data to move between private and public environment. With a hybrid approach, you have common data management for your workloads, while still tapping the sensitive data that might not be suited for a public cloud. Cloud service type S double A S, P double A S, and I double A S. First one is System as a software, means SaaS. Basically, SaaS represent all the applications that are managed by the third party and work based on a subscription. The user are not responsible for any maintenance or management of that software. Some example of SaaS include the Microsoft Office 365, Google Apps, Dropbox, SAP, Netflix, etc. Then platform as a software. The difference between SaaS and PaaS is that with PaaS is users already have a framework they can build upon to develop or customize application, but they are not responsible for managing the server or infrastructure. For example, if you would like to develop your own app, PaaS product could represent the platform to run the app onto. Some examples of PaaS are the AWS Elastic Beanstalk, Microsoft Azure, Google App Engine, Red Hat, OpenShift, etc. Then last one is the infrastructure as a service, the most flexible category of cloud services. Instead of buying hardware with infrastructure as a service, you rent it. You have complete control over the hardware that runs your application, server and virtual machines, storage, networks, and operating system. Some examples of infrastructure as a service are Amazon EC2, Windows Azure, Rackspace, Google Compute Engine, etc. Basically, infrastructure as a service offers ready-made infrastructure on which users can still visualize, access, install, configure, and manage their software. Virtualization security requirements. The trusted computing base, that is the TCB, of a virtual machine is too large. PCB is a small amount of software and hardware that security depends on and that we distinguish from a much larger amount that can misbehave without affecting security. Scenario: a client uses a service of cloud computing company to build a remote virtual machine. Then it can be implement a secure network interface, a secure secondary storage, and a secure runtime environment for build, save, restore, and destroy. In this session, we learn about virtualization and cloud technology and security. Means we learn about what is virtualization, what is hypervisor, and cloud technology. What is the cloud technology? Types of cloud technology deployments and services, and here the security. Thank you.